So now that we got this finished, let's go into our vertical cable simulation. Okay, and we'll start by dropping what we're looking at here, the name attribute, class. That looks okay, but I think we might have cut some of these. Let's do it again. I'm going to drop a connectivity in case there's any problem with this one, because I'm not sure if that was before the Boolean, so we could have some kind of floating primitives, you know. I'm going to set this to primitive, and then just take a look at this so we can see, you know, all the separate pieces. I'm going to measure this. It's not going to be something for use now, but for later on. So I'm going to drop a measure and use that class attribute that we just made. Okay, so I want to measure all these pieces. And then after that, now I'm going to drop a Boolean and do that same union thing because I want to join all these together. Okay, we've got all these separate pieces. We've got all these intersections there. So set this to union. Maybe what I'll do, because we've got a lot of pieces here and it could run a bit slowly, so let me just drop a delete. And we'll just do this by, I don't know, I'll just select a load of these. I'll just press delete after selecting them. I should have done it a different way, but like this is fine. Delete non-selected. Don't worry if you don't have exactly the same as me. It's just to, you know, get the process working, and then later on we'll get rid of this. Maybe let's make this red so that we know to delete it, you know, before we actually do our final simulation. Connect that in, make sure that's set to union, and there we go. So now after the Boolean we do another connectivity, and we should have a different result. Okay, so there we can see, and then I'm going to set that to primitive again, so it overwrites the previous value. So there now we've got each kind of, you can see we've got these four, well, kind of two bits of cable coming down, and they're connected at the top. Sorry, I'm just trying to get a good angle on this. So they're kind of curving over, and then that one piece of cable comes down, connects to this box at the bottom, and then that connects into one vertical kind of cable. All right, and that's all separate pieces. So we're going to treat each separate color here as one object in our simulation, and I'm going to use Vellum to simulate this because they're going to be so, you know, they're going to be much more active, bendy, and windy and springy compared to the previous simulation that we did, which was also a cable but much heavier. So the only problem with this is, you know, this piece in the middle here, that's really is kind of like a chunk of solid metal. This shouldn't be bending or stretching at all. So that's kind of what makes this difficult. So what we're going to do is drop a for each loop here. Okay, for each name primitive, that class attribute again. Okay, and then let's see the first piece there. So you can see that's each one of these is going to be one component of our simulation. I'll say it that way. So I'm going to drop a convex hull on this. Okay, and that's fine as it is. And maybe let's remesh this. It's good to, you know, your topology is very important for a Vellum simulation, right? So let's drop this down to 03, something like that. Okay, so how many, you know, the kind of width of these triangles, the size of your topology will affect how bendy and how stretchy your simulation is. So it's, you know, it's important to take that into account. I want to copy, so I'll just use an attribute transfer with this to be fine. I want to grab that class attribute back. Okay, so just on the primitives and the class attribute. Okay, yeah. So this just to explain, this measure, we're going to be using that because I want to isolate later on. I'll still have those values to isolate some of these pieces down here due to the way we're going to be processing this after the simulation. So we're going to simulate these and then again add that simulation to this geometry. However, we want to do it in a bit of a different way, so I want to treat these blocks differently to the rest of the cables because these blocks, you know, we don't want them stretching and stuff. Okay, so let's get rid of that. Now, parts of the animation of this is going to be coming from the cables that these are attached to at the top, right? And we've already got that animation. So the way you do that with Vellum is by pinning these points and adding the animation to them. Okay, so we're going to object merge that in. So if we go trying to find it, horizontal, and it's top cable cache, yeah. Okay, grab that. Okay, so that's the simulation that we just finished. So we need this animation to drive the top parts of these, yeah. So the way that we're going to do that, let me just group these. Don't know if we'll need it, but since this is our, you know, this is our simulation geometry, that cables, call them. Okay, so we're going to be grouping the top points here. So let's drop a group. This into the first input. And then this like this. So we could just do it like that, but the geometry on this side is not so clean. Okay, I'm going to make it simpler. So let's drop a time shift here and delete channel. So that's just on the first frame. Okay, so that when we make this group, it doesn't change. And just like before, we'll do VDB from polygons. Okay, oops. And do 05, something like that. Let's peek it again. Just to make sure that we grab. This doesn't need to be really neat. It's just to make sure that we grab points at the top of all of these. Okay, so this group we're going to be working on points. We're going to call this pin, and we don't need a base group. We want to keep in bounding regions, bounding volume, and there we go. So you can see there we're grabbing the tops of all of these now. Okay, we want to make sure that we don't miss any of these, because if we do, there's something weird going on. I think that's just from our selection there, but don't worry about that. So yeah, we need to make sure that we grab the top of all of these. Okay, so that's why we went to this trouble of making this nice and big. So we got our pin group there. Now we need the animation on this pin group as well, which we have here. Okay, so we use a point deform for that. Point deform, connect this into our first input. Okay, but we just set the group to pin because we only want, why is that not coming up? Well, let's maybe because we need to connect up everything else. We need the time shift there, so for the rest frame, and then the animation to the last one. And now can I have, there we go, got that pin group. So that's just the points at the top. And then when we move through, we'll see those top bits moving. So obviously that looks really weird and, you know, everything getting stretched out here. But in the simulation, you know, the rest of the geometry will follow along, get pulled up, and give us a nice result, hopefully. Okay, so we're on our way. Next, we need to add constraints to these and, you know, make them into, make them ready for simulation.